This week we're continuing to work with derivatives. We're going to do a couple examples of finding a second derivative and a couple examples using implicit differentiation. Now whenever you see a question like this with the root, it's best to write it in fractional form. Now to find the first derivative, we can just use the chain rule. So bring the exponent down, rewrite the inside, subtract 1 from the exponent, and then take the derivative of the inside. Simplify. Now we can start looking at the second derivative. Now when we go to take the second derivative, we now have to actually use the product rule because we have an x function times an x function. So derivative of the first, rewrite the second, plus the first, derivative of the second. To take the derivative of the second, we are just using the chain rule again. We can simplify. Getting us our final answer. Now here we're finding the second derivative again. We're going to use the quotient rule. From here we can simplify the top. Collect like terms, giving. But I'm going to rewrite this one, bringing the 5n minus 1 up to the power of negative 2, because to find the second derivative, we don't need to use the quotient rule anymore. We can just use a chain rule. And that's because there's no n's in the numerator. We only have a function of n in the denominator. So we take the derivative, simplify, giving us our final answer. Now this third example is what we call implicit differentiation. So we can take the derivative of the 2x fourth as normal, 8x cubed. The derivative of 3y to the fourth would be 12y cubed, but it was a function of y, so we multiply it by dy dx. When we go to take the derivative of the right-hand side, we have a product. X squared times y squared is a product, so we need to use the product rule. We take the derivative of the first, rewrite the second, plus the first, derivative of the second, but the second had a y in it, so it's dy dx. And then the derivative of 27 is 0, we don't have to write it. From here, we get all the dy dx's to one side. And then everything else to the other side. We can factor dy dx out of the two terms on the left. Divide. And in this example, we can also simplify taking a 2 out of each term. Our last example is another implicit differentiation. This time we have to use the chain rule. Now, before we simplify, the easiest way is typically to multiply this out. So I'm going to take this 3y minus x squared and multiply it by the dy dx and multiply it by the negative 1. This will give me I can move the second term over. And then divide. For our final answer.